Hello there, Mr. Victoria at the Science Cafe, and today we'll be discussing chemistry, topic acids and bases. And under this topic, we are going to be considering the area that talks about basic concepts of acids and bases. So, if you're ready, get your writing materials as we kick off. There are three basic concepts of acids and bases. When I say concepts, I'm talking about ideas. What ideas are actually raised concerning whether a substance is an acid or a base. It might interest you to know that in early times, that name always rings a bell in chemistry, the one that is often referred to as Antoine Lavoisier. In some of my videos, I've discussed Antoine Lavoisier. He is known as the father of modern day chemistry. Antoine Lavoisier actually proposed that oxygen was a major part of all acids. Actually, he named that word oxygen, and he said majority of substances that contain oxygen, or most substances that contain oxygen, could be said to be an acid. Well, he wasn't entirely right. He wasn't even right at some point. It was later discovered that hydrogen is the identifying mark for acids. And so as a result of that, I introduced to you three basic concepts of acids and bases. According to about 3 or 4 chemists, as the case may be, the first basic idea of what an acid or a base actually is was proposed by Arrhenius. So we call this Arrhenius theory or Arrhenius concept of acids and bases. His full name was Svante Arrhenius. He was a Swedish chemist, and he proposed the first theory of an acid and a base. In other words, he tries to give us an idea of what an acid and a base stands for. So when we see a substance, how do we know that this substance is an acid? How do we know it's a base? So he brought up his own concept. The second set of chemists have brought up their own concept of an acid and a base. Bronsted and Lowry, and the theory goes as Bronsted-Lowry theory. Bronsted-Lowry theory of an acid or base. Johannes Bronsted was a Dane from Denmark, and Thomas Lowry was an Englishman. They were working independently, and they got to realize that they found out something about what an acid and a base is, which we are going to present to you in our videos to come. And the third basic concept of an acid and a base was proposed by Lewis, and it's called Lewis theory. It's about the most modern of it all, of the three, them all. Lewis theory, an acid and a base. So we want to actually key into what an acid can be, or what an acid is, and what a base is. Not literally just saying it, not basically just defining it. Yeah, it's good to define what it is, but just in case we come across a substance, how do we know that this substance is actually an acid? How do we know that this substance we are playing with right now is actually a base? So it's very important that we know what an acid is and what a base is. And these three theories are going to help us to understand just that. So for the purpose of this class, for this video, we're going to be taking the first basic concept of an acid proposed in 1777 by Svante Arrhenius. We're taking Arrhenius theory of the acid and the base. So, what did Svante Arrhenius say is an acid? How did he identify his own acid? What ideas came up to his mind, and how did he share them? What did he actually say an acid is, and what did he say a base is, so that it can be of use for us today? Well, he said that an acid is a substance which, when dissolved in water, produces hydrogen ions, what we know it today as hydronium ions. So he said an acid is a substance which, when dissolved in water, produces hydrogen ions or hydronium. Some people call this hydrozonium ions. And listen, as a base is a substance which, when dissolved in water, produces hydroxide ions. A base, according to Svante Arrhenius, is a substance which, when dissolved in water, produces hydroxide ions. Now, some of us could have problems getting to know the symbolic representation of hydrogen ions or hydronium ions. I'm going to show that to you in a bit, as well as hydroxide ions. And if you're having problems getting to know how to write radicals, symbols of atoms, symbols of radicals and ions, watch my video on radicals and ions and valencies. It's going to really help you to write symbols, chemical symbols in simplistic terms. It is very important that you understand that if you really want to progress in the field of chemistry, because chemistry is more of the shorthand notations of chemical symbols. So watch my video on radicals and valencies. That's really going to help you understand how to write the short notations of hydrogen ions, hydronium ions, and hydroxide ions. So let us quickly see what Arrhenius meant by his definition of an acid in chemical equation terms right now. So we are going to represent an acid to be HA. HA. Let's call this an acid. Okay? It could be any acid. You know of some acids. You know of sulfuric acid. You know of hydrochloric acid. You know of nitric acid. You know of perchloric acid, and several other types of acids. But we're going to generalize these acids to be HA. Now he's saying that when you dissolve this acid in water, okay, basically when you dissolve the acid in water, which is a liquid, okay, you are going to have what is called hydronium ions. Hydronium ions. Hydronium ions have the formula H3O plus. I'm going to show you how this happens in a bit. And you're left with A. A carries negative charge. So the acid, when dissolved in water, gives you a hydronium or hydrozonium ion. Right? So this identifies an acid. But in some cases, you do not need to show the water in your equation. In other words, you could write it as this. AQ for the acid. AQ. I'm going to explain to you what that means too. When you dissolve a substance in water, AQ actually tells you that that substance has been hydrated, meaning the substance has been dissolved in water. So whenever you see a chemical reaction whereby AQ is written by the side in a bracket as a subscript beside the substance, just have it at the back of your mind that that substance has been dissolved in water already. That is why you can see that in the first equation I put up here, I did not put AQ, simply because I was just about to add water in initial terms. And after adding water, I got this. So it will be meaningful for me to write AQ here because it has happened after this has been dissolved in water. Okay, so this is all happening inside water. So I could actually bypass this equation by writing it straight ahead and say this is my acid already dissolved in water, and I'm going to be having H plus A minus AQ and AQ. Seems pretty easy, right? The second one is actually the most common form of writing acidic equations that is dissolved in water. So, but for the purpose of our definition, an acid is a substance which, when dissolved in water, produces what? This is the product. Produces hydrogen ions. Hydrogen ions. Or hydronium ions. That is what happens when you dissolve an acid in water. So any of the two equations will suffice, depending on the one in which you are asked to write. So this is what actually happens when an acid is dissolved in water. Alright? So if you were to take a classic example of an acid in water, you could take hydrochloric acid. So let's see. Hydrochloric acid has a formula HCl. Again, like I said, if you have problems writing the formula of chemical compounds, watch out for my videos on radicals and valencies and how to write chemical compounds. It's going to be very, very interesting. So HCl, in one way, I could just assume it has been dissolved in water already. So I put AQ, hydrochloric acid dissolved in water, gives me this H plus and Cl minus. This is what has been produced. This is the hydrogen ion, that is the chloride ion. So this makes me know that an acid is present. Alright? HCl is the acid. Now you might still be saying, I can't see the H plus with my bare eyes. So how am I supposed to know? Well, we are going to get there as soon as possible. Okay, so just hang on. Other examples could be H2SO4 dissolved in water to give me 2H. I am now balancing the equation. Okay, so you can also watch videos on balancing of equations, using ionic equations as well. 2H plus SO4 2 minus. You see, I know, I understand there are a lot of questions to ask. Okay, how come the minus, how come the plus, and all of that. Subsequent videos shows you all of that. So I am fixing AQ here and AQ here. You need not worry, everything will be explained exactly as it should be. So in your spare time, you could work on the dissolution or the dissolution, yes, of other acids in water. Other acids such as perchloric acid. Perchloric acid has the formula HClO4. You could also work on acids such as phosphoric acid. Phosphoric acid, where you have it as H3PO4. You can have hydrobromic acid. Hydrobromic acid, which is HBr, and so on. So what we've just shown you here is the chemical representation of Arrhenius theory of an acid, whereby an acid dissolves in water, that is represented by the AQ, to give you hydrogen ions, which is what we actually need. Alright, so in other forms, if you're not going to write it this way, you could go straight to saying hydrochloric acid reacting, or hydrogen chloride reacting with water to give you the H is what we're looking for, but it has to combine with the water. The problem here is this, or should I say the idea here is this: water has the ability to draw out hydrogen from hydrogen chloride. Okay, you know, some substances are stronger than others. When you mix one or two things together, in most cases, one of those two things has the power of pulling. You've played a game called tug of war before, where you have people at opposite ends pulling a rope, okay, at each other. And if I'm standing at A and the other is standing at B, well, depending on the strength of my strength or B's strength, I could have the ability to pull towards me more than B, or B could have the strength to pull towards himself or herself than me. And so in a situation where we have hydrochloric acid mixing itself with water, water has an ability to pull away hydrogen to itself, leaving behind chloride ions in solution, that is in water. So if there is a pull occurring, it means you're going to be having H2O Or should I say water is going to pull hydrogen ions to itself? So you're going to be having a combination of H2O plus H, giving you this hydronium ion plus chloride ions. So what actually happened here is this. H plus from the chlorine, HCl, this is a bond holding HCl together, more videos on bonds later. HCl plus H2O, this is how it looks like. This is 2 hydrogens and 1 oxygen. Okay, I'm just bringing out the bonds to show you what is actually happening in here. Okay, so water has the ability to pull hydrogen. Now what happens here is hydrogen breaks away. This is a bond with hydrogen and chlorine. Hydrogen breaks away from chlorine, and then because of the pulling effect that water has on the soap. When water pulls, as indicated by that arrow, when water pulls the hydrogen, it breaks away the bond that it has with chlorine. Okay, and so you're going to be having something of such, and then a plus. This is what is going on there, plus Cl minus. This is what Svante Arrhenius was actually talking about in chemistry terms. Okay, so let's start with it here so that we can see clearly Cl minus. You can still see it over there, you know, it's forming Cl minus. So, an acid dissolved in water to give you hydronium ion. So you could try other examples of acids with this same model in your notes later on. Okay, so all you need to do is follow up with the videos, repeat it, because they say that repetition is the mother of skill. You can't learn this all at once. All you just have to do is follow the teaching and get your piece of paper and try to take examples of acids like I showed you on the board earlier. Pause and play, keep learning it until it becomes a part of you. Now let's move over to Arrhenius' theory of a base. What did Arrhenius say a base is? As already explained, he said that a base is a substance which, when dissolved in water, produces hydroxide ions, and the symbol for an hydroxide ion is OH minus. OH minus. We're going to get to know all about this in our subsequent videos. OH minus. And now, an example of a base in this case is the popular sodium hydroxide. But if you've seen sodium hydroxide before, most of it appears as pellets, solids. Okay, solid pellets. And the formula is NaOH because sodium has the symbol Na. The hydroxide is OH, so you have NaOH. Sodium hydroxide are white solid pellets, okay, in solid form, kind of whitish. When you dissolve it in water, you are supposed to have the following. You're supposed to have sodium ions plus hydroxide ions. Okay, so we could say we're going to be having 1 sodium here and 2 oxygens and 3 hydrogens. Or better still, we could still have it in water. Okay, so sodium hydroxide in water gives you the hydroxide ion, which is what signifies a base. Alright, so other examples of bases are the bases or are the substances that produces hydroxide ions in group 1. So the group 1A metals, the hydroxides of the group 1A metals also form bases. They're also called alkalis. The ones that dissolve in water are called alkalis. So we're saying here that bases that dissolve in water are called alkalis. So alkalis are soluble bases. Alright? Now to tell you that not all bases dissolve in water. And so we can rightly say that all alkalis are bases, but not all bases alkalis. Please get that paradox very carefully. We say that all alkalis are bases, but not all bases are alkalis. Why is that? Because bases that dissolve in water are called alkalis. So any base that will dissolve in water is called an alkali. So not all bases are alkalis. So that does it for Arrhenius theory of acids and bases, as you've seen. Arrhenius said an acid is something that dissolves in water to form hydrogen ions or hydronium ions, whereas a base dissolves in water to form hydroxide ions. In our next class, we are going to see the other concepts of an acid and a base, the concepts that include Bronsted and Lowry, as well as Lewis, and then going to take us further to ideas like neutralization, how an acid neutralizes a base, and vice versa. So, if you have any questions, like I used to say, you can call me on this number. Plus, very soon we're going to be engaging all of us. If you're following this edition of Science Cafe, if you're following the Science Cafe and you're a student, we're going to be engaging you guys as soon as possible. We want to make sure Science Cafe is for every student of chemistry, students of biology, students of physics, and as time comes up, students of mathematics as well. So we find this to be very engaging, very appealing as time goes on. So please be up and doing. And remember, if you want to be an A student, create an A plan. Study how to make A's. And this is the right place to be. I'll see you in the next video.